Hello everyone.
Welcome to another online module.
This one is going to be related to
this week
the
we're going to
spinal
focus on the
column
vertebral
and the associated
Now
muscles and joints.
this is two different chapters in the Laminectomy
This
textbook.
unit is really focused on two
spend
chapters in the
most of
book. However,
on
I'm going to direct you
chapter 4,
to chapter 4,
which is related to a lot of the joints and the mechanics there, whereas chapter 13 is related to posture. So if you were to split this up, I would say spend about 10% of your time related to chapter 13 and about 90% of your time related to chapter 4, which is also what the PowerPoint and the class sessions will go through as well. So let's get going with this. As we talk about the vertebral column, you'll notice that the bony morphology is set up into different regions, and there are alternating convexity and concavity to them. So let me get my highlighter out here. So you could see at the cervical spine, we have a lordosis, which is followed by a kyphosis. The lumbar spine, we have a lordosis again. A lordosis is going to have a convexity anteriorly and a concavity posteriorly. And you can see how that's oriented in these different ways. One way I thought to remember that, we have 23 discs, and Michael Jordan, MJ, is number 23. So if that helps to remember, 23 discs. And you can see the alignment of those, and then certainly with aging and postural considerations, there are some changes to this. Now, speaking about the Selective Functional Movement Assessment, the SFMA, a little bit, you know that there's the top tier of 10 movements, and the question, how many of the top tiers are focused on spinal movement patterns? So if you look at this, obviously the first 3 are, so you have 3 there for cervical flexion, extension, and rotation, and then you also have multi-segmental flexion and extension, and then you have multi-segmental rotation. And granted, some of these movements, these ones especially, do come from the hips. They're largely related to the trunk and spinal mobility. So you can see that 6 or 60% of these top tiers are related to spinal movement. And so it's a foundational movement that we have to have in order to move our extremities and move about for our sports or our daily activities that we're performing. Our spine has to move very critically. So spinal mobility and movement is of chief importance. And so let's look at the vertebral column a little bit. You can see, how we're formed. We have basically one big kyphotic curve while in the womb, and then as we start to walk and move around and bear weight, you can see that these curves start to develop. So we start to get this lordotic curve here and a little bit of a lordotic curve here. But in particular, when we're crawling and when we're upright, we get the cervical spine, and then when we start walking and running and moving, we really start to build that lumbar lordotic curve, and it's interesting how that develops. Okay, so that's what happens there. So you can see that we have this kyphotic nature initially, as we're not upright and moving, and then over time and with function and motion, that becomes a lordotic curve. And consequently, as we get older and if we become more sedentary and we spend more time in bed and less time walking, we also revert back to our kyphotic type positions. Now, typically, when do these curves develop? Children, babies, are generally able to hold their head up around 3 months, and then around 6 months, they're usually sitting and crawling, and then typically 9 months is early, so I think 12 months is a pretty good standard for when a baby typically starts walking. But those are just some general figures. So in this picture, you can get an appreciation for, as we're children, the curves are developed, but not as extensively because we don't weigh as much, and we're not bearing weight the same manner as when we're adults and we develop more of these pronounced curves. But in general, lumbar curve seems to develop when we're sitting upright, and this tends to happen within 4 to 6 months. So now we spend a little bit of time looking at the orientation and the layout of the vertebrae. You can see that you have this dividing line, basically, where you have the vertebral body, the disc would be right there, but you have this anterior portion, and then you have this posterior portion. And when we talk about spinal movement, sometimes we're focusing on P to A mobility or posterior to anterior mobility. So if you have someone on their stomach and they're receiving immobilization, we typically press over the spinous process or over one of these posterior elements to determine the mobility of the spine. Now within there, you can see right in there would be your spinal cord, and you can see that you have the pedicle here as this bridge basically between the anterior and posterior portions. So as we look closer at this, you're also going to notice these portions. You have your articular processes, or your xipophyseal, or your facet joints, which are going to be important structures for the mobility and the kinematics within your spine. You can see the lamina is pictured here, and so what would happen in some surgeries, they would do what's called a laminectomy. So they would cut the lamina, and they might remove this portion, they might secure it with some type of hardware, or they may return the lamina in place. But you could have a laminectomy or a removal of bilateral lamina. Now in this condition, it's a little hard to pronounce sometimes, but spondylolytic, spondylolisthesis, and sometimes we just nickname these spondies, is how we can sometimes refer to them. So you can see the slippage here, and just a few things to point out. As you look at the vertebrae, you can see the vertebral body is here, and if you notice the shape of it, from anterior to posterior portion, you can get an appreciation for how the anterior portion is basically taller than the posterior portion. So this is known as a wedge shape, and we typically have this wedge shape at these lordotic sections, and this helps to add some of the lordosis or the curvature to our spine and helps to provide a support. So with that, you can see that there's a listhesis, which means you have this pars interarticularis, which is fractured. Sometimes on an x-ray you'll hear that as the Scotty dog fracture, because when you're looking at this, I can't draw this too well, but it looks like a Scotty dog, or some people think it does, so it's nicknamed a Scotty dog fracture. But you have a listhesis here, and with a listhesis you have a fracture and you have a slippage, or you might even say you have a shear or a translation of the vertebral body on the other section. And this can occur basically in two directions. So you could get the shift going this way, so that would be an anterior listhesis, or you can get the shift going in the opposite direction, a retrolisthesis. And on x-ray and other imaging, they can basically measure this, typically in millimeters, to see how much of a listhesis there is, and that may determine the extent of this. However, before you get a listhesis, typically with this, you get a slight stress reaction, or notice with this. So sometimes they just call this a spondylolisthesis, which means the pars interarticularis is weakened, or maybe has a slight fracture in the area, but there's not a slippage yet. So that could be an early warning sign of a potential spondylolisthesis if there's a lysis, spondylolisthesis present. Now, anatomically, there are some portions of our body that are a little more prone to this because of the curvature, this lumbosacral angle that we have here. It's a little more likely to occur at this L5, S1 segment. Although everyone's morphology is slightly different, that's just a common theme that we see. And here it says forward slippage, but we would call that also an anteriolisthesis. Now, one of the issues is compression of the nerves on the cauda equina. So you could see if there's a slippage there, then you may have bony segments going into the spinal cord, which is running up and down here. Now, as you look at this image, what do you notice? So you could see the remnants of the spinal cord, or let me go to blue here, so the horse's tail in there, and you can see very much a compression of that. So these are the vertebral bodies, obviously, vertebral body, and within that you have the intervertebral disc, the IVD, which is there, and so you have a listhesis going in that direction. So if it's going posterior, we would call that a retrolisthesis. And that is significant. Last slide here, just a little true-false question. Curves that have a posterior convexity, so they would look like that, so posterior convexity and anterior concavity are known as kyphotic curves, and that is true. So if you look at the spine here, you're going to have a kyphosis at the thoracic spine, and that's going to be followed by a lordosis at the lumbar spine, and then a kyphosis at the sacral spine. Okay, that's the first one. I'll see you on the next lecture.